we're going to start talking about two-column proofs. All right, so from algebra, we already know how to solve this problem, right? The goal is to get x by itself, right? And we would show all of our steps to solve that, right? So we're basically going to practice solving algebra equations, but then writing out what properties we're using for each step, kind of like we've been doing the last couple days. So it's not going easily. Oh, it is. Okay. So when you have a proof, you're going to have something that's called your given, right? So that's always going to be your first statement. Right, so like on the left is basically where we're going to be solving the equations. On the right is going to be where we're writing each property that we've used. So like, for example, right, we can see from step 1 to step 2, we've moved this x over. So therefore we have subtracted it, right? And we're now left with the equation 3 equals 4x minus 8. Okay, next, we can see that from 2 to 3, we have moved that 8 over, which gives us 11 equals 4x, right? Again, the addition property is what allows us to add that 8 to both sides of our equation. Right, next step to get x by itself is to divide by 4. Right, so again, that's our division property. And then since in our proof statement up here, it has x equals 11 over 4, we need to flip that around. Even though mathematically this is fine, but the proof wants us to flip it around, and sometimes you'll have to do that. So we're going to use our symmetric property. Okay, so I know that was kind of a lot, but that's just a quick example. We're going to go through some in a lot more detail here in just a second. Okay, so let's look at another sample proof. So this time we are given that ABC is congruent to DEF, and angle DEF is congruent to angle JKL. So both of these statements are given to us, so that's where we're going to start. I wrote statement 1 here, statement 2 here, and those are both given to us, so that is our justification or our reasons for that. Okay, so then we're trying to prove, so like this is our end goal here. So we're trying to prove that angle ABC is congruent to angle JKL. So we are going to look at our given and see how we can prove that. So again, look, so ABC is congruent to DEF, and DEF is congruent to JKL. So we know that we can use our transitive property to say that those two things are congruent, which is what's happened here. So in line 3, we went ahead and wrote that ABC is congruent to JKL, and we said it is the transitive property of congruence, right? So this part here is just telling us that we used lines 1 and 2 to come up with that statement. Again, this is a short proof. We don't always have to fill all these boxes, but we just like to give you plenty of room in case you need it. Because there are times where there's going to be different ways you can do it, so it may take some of you some more steps, and some of you might take a shorter path. All right. So, let's do one together. So, step 1 is to copy down both of our given statements. So, our givens are x over 10 equals 3, so this one, and y minus 5 equals 25. So, our next step is going to be to solve that first equation for x. So, to do that, to get things out of the denominator, remember we multiply both sides by 10. So since we are multiplying both sides by something, that means that we are using our multiplication property of equality. So again, I multiplied by 10 here, which canceled out, multiplied 3 by 10, which is where I got my 30. Alright, so then, now that we know what x is equal to, we need to find what y is equal to. So, we're going to solve our second equation, right? Because again, we're trying to show that x is equal to y. So if we can show that they both equal the same number, then we can use our transitive property to show that they are equal to each other. So, solving my second equation, right, I need to get y by itself, so I'm going to add 5 over to both sides, meaning that I have used my addition property of equality, right? And we know that y is equal to 30. So, now we know that x is equal to 30 and y is equal to 30. So we can use our transitive property to say that x and y are equal to each other. So, let's do this one together. So, step 1 is going to be to copy down our given statements. So we know that m is equal to n plus p is equal to 2t, and t is equal to m. Right, I'm just going to give you a second to get those copied down before we move on. Okay, so we're trying to prove that p is equal to t. So let's look at what we have here. We know that n plus p is equal to 2t, right? But we don't have anything about m in that statement. So we have n, p, and t. So let's use statements 1 and 3 to give us something that is going to get n and t equal to each other. So again, since both of these are equal to m, we can say that n is equal to t, and that is the transitive property. Okay, so now we can take this n and replace it with a t, and that is substitution. So now let's solve this equation. So we need p equal to t, so let's move this t over. So that is subtraction. So then p is equal to t. Alright, so again, there's lots of ways we could have got here, but the goal is to just use our properties, right, of equality as well as transitive and substitution to get to this end goal. Okay, so I know this is a lot. I know you guys are probably freaking out right now. It is okay, right? Honestly, this example is that we just did is a lot more complicated than any kind of practice ones I would give you at this point. So make sure you get these notes down. Miss Jones has a worksheet for you. And just try your best on the practice, and we will go over this all again together on Monday, right? I'm going to take time Monday just to review everything we've done this week just to make sure everybody's good to go.